Hello, today we're going to be going through some fin maths questions. Specifically, we're going to be going through my tutorial 1 from 2025. So question 1 says, Maria deposits 100 into an account at the beginning of each 4-year period for 40 years. The account credits interest at an annual effective rate of I. The accumulated amount in the account at the end of 40 years is X, which is 5 times the accumulated amount in the account at the end of 20 years. Calculate X. So with these questions, there's a lot of information, so it really helps to draw a timeline. So I'm going to draw a timeline starting at 0 and ending at 40 years. Okay, so let's put some sample points on just to show all the information we have. So I'll go to 12, then I'll have a little break, then I'll put 20, 24, have a little break, 36. Okay. So she deposits 100 into the account at the beginning of each 4-year period. So she's going to deposit 100 here, 100 here, 100, 100, 100, 100, 100. And this will be the last time she deposits because she deposits at the beginning. So she won't deposit here. Cool. So now what we should do is, instead of working with I, which is the annual effective rate, I want to define a 4-year effective rate. So I'm going to call it J. So I'm going to say let J be the 4-year effective rate. Cool. So now we probably want to write down equations. One more thing we should put on our graph is this information. So at the accumulated amount at the end of 40 years is X. So accumulated amount here is X. And the accumulated after 20 years is going to be X over 5 because it says the end at 40 years is 5 times the accumulated at the amount after 20 years. So after 20 years, it's going to be 1/5 of what was accumulated at 40. So these are the blue amounts of the accumulations at that point in time. So we probably want to write down formulas now, which will work out how much is accumulated. So let's start with the X. So that's the accumulated at 40. It's going to be, we're going to use future value annuities. So you're putting in 100 Rand each 4 years. So we're going to multiply that by a future value annuity for a period. For how many periods? We've had 10 because we are doing 4-year periods and it's up to 40. So it's going to be 10 periods and at an interest rate of J. Cool. So now we want to write down a formula for X over 5, which is the accumulation at time 20. So it's going to be 100 times future value annuity, but for 5 periods now because you only have 1, 2, 3, 4, 5. Again, at an interest rate of J. And they're all in advance because we're putting in the money in at the beginning. That's why you have the dots. Cool, so now we have 2 equations, equation 1, equation 2. So I'm going to write equation 2 in a way just to make it a little bit easier. So I'm going to multiply both sides by 5. So I'm going to say X is going to be 500 times this annuity. Perfect. So now we have 2 equations and they both have an X, so we can equate the X's. So we can say that 100 times the annuity is going to be equal to 500 times this annuity. Perfect. Now the easy thing we can start with is just dividing both sides by 100. So we can say that the annuity for 10 periods is equal to 5 times the annuity for 5 periods. Cool. So now let's just remind ourselves what the general formula for an annuity for like n periods is, for example. The general formula for an annuity in advance, future value annuity in advance is going to be 1 plus j to the power of n minus 1 over 1 minus 1 plus j to the negative 1. That's the formula. So now what I'm going to do is I'm going to expand it. So I'm going to expand the left-hand side to be 1 plus j to the power of 10 minus 1 over 1 minus 1 plus j to the power of negative 1. That's going to be equal to 5 times 1 plus j to the power of 5 minus 1 over, draw a nice line, over 1 minus 1 plus j to the negative 1. Cool. So I'm going to start with is I can see there's a common base. I'm going to multiply both sides by just to get rid of it. So we're going to get 1 plus j to the power of 10 minus 1 is going to be equal to 5 times 1 plus j to the power of 5 minus 5. Remember to multiply them into both. Cool. So I can see this looks quite a lot like a quadratic because we have something to the 10, something to a 5. So if we use the k method, we can get a quadratic. So I'm going to say let k be equal to 1 plus j to the power of 5. Cool. So now then this will become k squared. If we move this across, this will become minus 5k. Minus 5k, and then you have a minus 1. You move this across, plus 5 becomes plus 4 equals 0. We can easily factor this into k minus 4. K minus 1 equals 0. Therefore, k equals 1 or k equals 4. Cool. So now let's consider if k equals 1. Let's start with this one. Okay, so if k equals 1, then we get that 1 plus j to the power of 5 equals 1. If we raise both sides of the 1 over 5, we get 1 plus j equals 1. Therefore, j equals 0. So normally, if you get an interest rate equals 0, you often say it's not applicable because you often want your interest rate to be like greater than 0. So I would say this one would be not applicable. So we wouldn't really consider this one. So then k cannot be equal to, so like you wouldn't really consider that. So we're only really going to consider the one for if k is equal to 4. Okay, so then we will say 1 plus j to the power of 5 is going to be equal to 4. Cool. So then we'll get 1 plus j equals 4 to the 1 over 5. So we'll get j equal to 4 to the 1 over 5 minus 1. Perfect. So now, if I sub this into my calculator, I'll get j be equal to around about 31.95%, which I will save in my calculator as A. And this, let's just remind ourselves what this is. This is the effective 4-year rate. So this is your interest rate per 4 years, effective. Cool. And the great thing is that we have our overall goal is to find x, and we have a formula which gives us x in terms of the 4-year interest rate. So we can just sub our j in, and we should get the right answer. So I'm going to say x is equal to 100 times the future value annuity in advance for 10 periods at an interest rate of j. So it's going to be 100 times 1 plus, I'm going to use a instead of j just because we saved it as a to the power of 10, minus 1 over 1 minus 1 plus a to the power of negative 1. And when I sub that into my calculator, I'm going to get 6194.72. That's your answer. X is equal to 6194.72. So 619.72 is going to be your accumulated amount at the end of 40 years if you deposit 100 in and you have this as your effective 4-year rate. Okay, so now we're going to be going through question 2. So question 2a says calculate the present value of an asset that pays 100 Rand in 10 months and 200 Rand in 12 months time. Assume a force of interest of 5% per annum for the first 6 months, an effective rate of discount of 12% per annum for the next 3 months, and a rate of discount convertible monthly of 5% per annum for the final 3 months. So what I like to do for these ones is I like to draw a timeline again because it'll help us to visualize all the information. So we're going to go from month 0 to month 12, and I'm going to write down when all the important stuff happens. Something happens at 6, something happens at 9, and something happens at 10. So it says that it pays 100 Rand in 10 months time. So at 10 months, we're going to get 100. And then at 12 months, we're going to do 200. Cool. And we're going to try present value this. So we're basically trying to bring both of these amounts back to time 0. So now let's write out what our interest rates are for the period. So for the first 6 months, it says we have a force of interest of 5%. So I'm going to say delta is equal to 5% for that period. And it says for the next 3 months, we have a rate of discount of 4%. So I'm going to say D equals 4%. And then it says for the next 3 months, your rate of discount convertible monthly. So you'll put a little 12 here for monthly, and it will be 5%. Okay, we need to work out the present value of this. So what I'm going to do is I'm going to work all these out in effective interest rates. So I'm basically going to convert all of these to effective interest rates. So let's convert the force of interest one first. So we know to get delta, the formula is delta is equal to ln of 1 plus I. Okay, so we want to get I from this. So that means that tells us that I will be equal to, if we raise both of them to the power of e, it'll be e to the delta, and then we'll have to subtract 1. Cool. So if we want to get, let's call it interest rate 1 for this period. So for this period, interest rate 1 will be e to the power of 5%, so 0.05 minus 1. And if you plug that into your calculator, that's going to give you 0.0513, and let's save that as A to use for later. Cool, so that's going to be our interest rate for this period. So now our interest rate for our second period. So we've got a rate of discount, and let me just put a little like a number 1 here, so that's our first calculation. So for our second period, we can use the formula that D is equal to I over 1 plus I. So that tells us that D, which is 4%, so 0.04, is equal to I over 1 plus I. So I'm gonna multiply both sides by 1 plus I, so you get I is equal to 0.04 plus 0.04 I. Cool. So now I'm going to move this I across. So we get 0.96 I is equal to 0.04. Therefore, I is equal to 1 over 24, which is approximately 0.04167, and we'll save that as B in our calculators. Cool, so now we've got the effective yearly interest rate for that period, and we've got the effective yearly interest rate for that period. So now we've just got one more to do. Okay, so I think a good start for this one would be to use this relationship. So for period number 3, we're going to use that 1 plus I is equal to 1 minus d12 over 12 to the power of negative 12. Cool. So what we'll do from here is we'll just say I is equal to 1 minus, and d12 we said was 5%, so it'll be 5% over 12 to the power of negative 12 minus 1, and that'll be 0.0514, and we'll save that in our calculators as C. Okay, so now we've got all our interest rates. So now to find the present value, it should be pretty simple. So we're going to first want to move this 100 Rand all the way to the present value. So we're going to have 1 month with the interest rate C, we're going to have 3 months with the interest rate B, and we're going to have 6 months with the interest rate A. So we're going to take 100 Rand, and we're going to multiply it by 1 plus C. And remember, all our interest rates are in annual, so we're going to raise it to the power of negative 1 over 12 to find the present value. Okay, so that's the 1 month for C. And I'm going to do 1 plus B to the power of negative 3 over 12. And I'm going to multiply that by 1 plus A to the power of negative 6 over 12. So, as I said, 6 months of A, 3 months of B, 1 month of C. And this is how you present value is. Cool. So now we're going to have to present value the 200. So it's going to be pretty similar, except now it's going to have 3 months of this. So let me just write. This is like our information. This is our interest rate C. This is B. This is going to be A. Cool, so now we're going to have like 3 months of C, 3 months of B, and 6 months of A. So that's going to be 1 plus C to the negative 3 over 12 times 1 plus B to the negative 3 over 12 times 1 plus A to the power of negative 6 over 12. Perfect. When you plug that into your calculator, for the first one, I get 96.13845, and for the second one I get 190.6779, and when you add them together you get 286.82, and that's everything you have to do for A. Perfect. Now let's move on to question B. So B says find the amount of a single payment at time 6 months from the present time that is equivalent to the payment in part A. So basically what we're going to have to do is we're going to have to find, let's draw a timeline for this one again. So for B, we have 0, 12 months, and 6 months. And we want to make one single payment here. And we want to make it have the same present value, because remember, this is our present value that we found in A. We want it to have the same present value as this. This should be quite easy. And overall, we're trying to find the amount, yeah. So since we're doing it at 6 months, it should have it's going to be just this interest rate, so it's only going to be at an interest rate of A. So we can do it pretty easily. So if we discount our amount of X to the present value, our present value should be the same, so it should be 286.82, and it's going to be equal to 1 plus A to the power of negative 6 over 12. So we're basically taking this amount X, we're discounting it back 6 months at our interest rate A, because our interest rate A was for the first 6 months. Perfect. Now if we solve this out, it should be pretty simple. Yeah, and you have to multiply all this all by X, so we're basically discounting X by this amount. Perfect, yeah, that's correct. And all you have to do is divide both sides by this amount, and you'll get that X is equal to 294.08. So basically, if you paid an amount of 294.08 and you discounted at the interest rate A that we worked out here, which is like 5.13%, you would get this present value. Cool, so B is pretty simple. Now let's have a look at C. What does C say? C says, using the same interest rate structure as in A, calculate the present value of a payment of 100 Rand monthly in advance for the 12 months. Okay, so again, let's do a timeline. This one looks a little bit more complicated. Let me draw it nice and straight. Perfect, so I'm going to go from time 0 to time 12. I'm going to just write in all of them just to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Cool. And let's also write in where our interest rates are. So we have that period, we have that period, and we have that period. Cool. So we know over this period it has interest rate at A, which we calculated. Over from 6 to 9 it has from 6 to 9 it has interest rate B, and then over this one is interest rate C. Perfect. So yeah, so what we're going to do is now we're going to basically pay 100 Rand in advance each month. So 100, 100, 100, 100, 100, 100. Let me just write them all in. Cool. And we're paying in advance, so this will be our last payment, because basically this payment is for like this period. Perfect. So now it's going to be a lot easier if we work out our interest rate per month. And it's going to be a lot easier for this question. So we can remember our general formula to convert between effective and nominal is 1 plus I effective is going to be 1 plus I nominal over n to the power of n. Perfect. So what we want is we want our basically our okay, so basically what we want is we want our effective interest rate per month, because this is the effective interest rate per year, but we want it per month. So to get our interest rate per month, we're going to say 1 plus A to the power of 1 over 12 minus 1. So basically, we're like doing the reverse of this, because we have the effective interest rate, and we're trying to find the nominal. So we're trying to do per 12 months, so we do 12 here. And if we raise both sides power of 1 over 12, and then we subtract this one, we're going to get I n over n. So this gives us like interest rate per 12 months over 12. And this is your effective monthly rate. Cool. So this is your interest rate per month for the first 6 months. And this gives you a value of 0.0042, and we're going to save that as D in our calculators. Cool. So over this period, our effective monthly rate is D. Cool, so now we're going to do the same for the other two. So this is like for period 1. For period 2, we're going to say 1 plus B. So the power of 1 over 12 minus 1 is going to be equal to 0.0034. That's going to equal to E. So we'll say that for this period, E is this is our like monthly effective. Cool. And now finally for the third period, for the last 3 months, it's going to be 1 plus C to the 1 over 12 minus 1, and we get 0.0042, and we're going to say that as F. Cool. So now we can basically do a bunch of annuities using these respective interest rates. So let's first do these first 6 payments, because these will be a nice easy one. So 1, 2, 3, 4, 5, 6. Okay, so these are all going to be in an annuity, and it's going to be in advance. Our present value is going to be the amount, which is 100, times an annuity in advance, and for 6 months, and we can do it at an interest rate of D, because D is our monthly effective interest rate. Cool. So we've done these. So now we're going to do these. So it's going to be 1, 2, 3. And we're going to present value all of these. So we can see these are also going to be an annuity. So if we do a present value for 3 months, it's going to take all those back to this point. And we still need to move those back another 6 months to get them to be the present value. So it's going to be 100 months times an annuity in advance for 3 months at an interest rate of E. And then we have to times that. So we're going to times that by V, which is the present value is it, for 6 months at an interest rate of D. Remember, because we're taking these 3 payments, we're taking them all back to this time, and we have to take them back another 6 months. So that's why we do it, and it's at D because it's over this period. Cool. I'm going to say another 100 for the last 3, times annuity in advance for 3 months at an interest rate of F this time because it's for these payments, so we're taking them all back to time 9 at an interest rate of F. And we have to take them back another 3 months, so it's going to be take them back another 3 months at an interest rate of E, and we're going to have to take them back another 6 months at an interest rate of D. Perfect. So let's expand this so we can type it into our calculator. So it's going to be 100 times 1 minus 1 plus D to the power of negative 6 over 1 minus 1 plus D to the negative 1 plus 100 times 1 minus 1 plus E to the negative 3 over 1 minus 1 plus E to the negative 1. We have to times it by 1 plus D to the negative 6 plus 100 times 1 minus 1 plus F to the negative 3 over 1 minus 1 plus F to the negative 1 times 1 plus E, to the negative 3 times 1 plus D to the negative 6. Cool. And if you've saved anything in your calculator correctly, you should get 593.79747 plus 291.6 plus 288.417. And if you add all those up, you should get 1173.81. And that's all of question 2. Okay, so next we're going to be having a look at question 3. So question 3 says a student has the opportunity to invest 3,000 Rand with Bank A. At the start of the year, the investment matures at 3,300. Bank B offers her immediate interest of 272 Rand and 73 cents for the initial investment of 3,000 and a return of 3,000 at the end of the year. Which bank should the student make her 3,000 Rand investment? Explain. Okay, so question 3A. So with these kind of questions, again, you should draw a timeline. That's always your first step when doing financial math questions. So let's do for A first. So for A, at time 0, she's going to invest 3,000. So she's going to lose 3,000. And then at the end of the year, she's going to make back 3,300. Cool. That's A. And now let's talk about timeline for B. So our timeline for B is at time 0. She's going to deposit 3,000 But then she's also immediate interest of 272. So she's immediately going to get her interest, 0.73. And then at the end of the year, she's going to make back 3,000. Perfect. So those are all the cash flows. So let's work out her interest on A. So the return. Let's work out the return of A. So basically what you're going to do is you're just going to create an equation and work out what the interest rate would be. So if you had an amount of 3,000, so that's going to be like your expenses, and it's going to be equal to your income, but at the same time. So we're basically going to present value this income and see what interest rate would be implied by that. So 3,300, and if we are present valuing it, we're going to multiply it by 1 plus whatever the interest rate is per year to the power of -1. Cool. So now all we have to do is solve this equation. So we get 1 plus I to the -1 equals 10 over 11. Flip both sides, so we get 1 plus I equals 1.1. Therefore, I is equal to 10%. Perfect. So the return of A is 10%. So now let's work out the return of B. The return of B. Okay. So you can take. So basically, she's not actually depositing 3,000 because she's getting some of it back. So we'll work out what the overall effect is. So it'll be 3,000 minus 272.73. So that's like your expense at the beginning of the year, and then she gets 3,000 at the end. So it'll be equal to 3,000, but present valued, 1 plus I to the -1. Let's see what interest rate is implied here. So we're going to get 1 plus I to the -1 is equal to 0.90909. If we flip both sides, we get 1 plus I is equal to 1.1. Therefore, I is equal to 10% again. So we can see that both offer the same return. Both offer the same return. And if you want to sound really fancy, you can say, therefore, she is indifferent between bank A and B. Cool, and that's question 3. Okay, so now let's have a look at question 4. So question 4a says, Nkosinati receives cash flows of 100 Rand today, 200 Rand in 1 year, and 100 Rand in 2 years' time. The present value of these cash flows is 364 Rand and 46 cents at an annual effective rate of I. Calculate I. So to solve this one, surprise, surprise, we're going to draw a timeline once again. And we're going to put all our cash flows in. So at time 0, we get 100 Rand. In 1 year's time, we get 200 Rand. And in 2 years' time, we get 100 Rand. So now, to work out I, we have the present value as well. So we can say the present value, which is equal to 364.46, is equal to, so 100, which is already at the present, and now we want a present value that's 200. So it's going to say 200 multiplied by 1 plus I to the -1, because we're discounting for 1 year. And then it's going to be, and now we want a present value of 100. So it's a present value, so we're going to multiply by 1 plus I to the -2, because we're doing it for 2 years. Perfect. So this kind of looks like a quadratic to me. If you set something to the 2, something to the 1, it's kind of like a quadratic 6. I'm going to say let 1 plus I to the -1 equal k. So we're going to get 100k squared plus 200k. And then if we move this across, we're going to get minus 264.46 equals 0. Cool. So now you can use the quadratic formula to get k equal to 0.90908, or k equals to negative 2.90908. Okay, so let's think about if both of these fit. This one seems like it makes sense, but this one doesn't make sense. And the reason it doesn't make sense is because an interest rate is always positive. And if you have a positive number to an exponent, you can never have a negative. So this one doesn't make sense. So we'll say not applicable for our negative case. So the only one we're going to use is this one. And now to get our interest rate, we can just say 1 plus I to the negative 1 is equal to 0.90908. And if we solve that, we get 1 plus I equal to 1.1. Therefore, I equals 10%. So your interest rate is 10% if these are your payments and that's your present value. Okay, so that's A. Let's have a look at B. B says, at a nominal interest rate of I, convertible semi-annually, so this means it's convertible twice a year, so it's a nominal rate, an investment of 1,000 Rand immediately and 1,500 at the end of the first year will accumulate to 2,600 at the end of the second year. Okay, so let's draw a timeline. So at time 0, it says we have an amount of 1,000, and at time 1, it says we have an amount of 1,500. And this will accumulate to, so the future value of this will be 2,600 at an interest rate of I, convertible semi-annually. And it says we have to work that out. Okay. So what I'm going to do is I'm just going to work it out. I think what I'm going to do is I'm going to work out the interest rate, like the effective interest rate annually, and then I'll convert that to the semi-annual interest rate. Okay, so I'll say the future value, which is equal to 2,600, is going to be equal to our future value, this 1,000 forward. So it's going to be for 2 years. So it'll be 1,000 multiplied by 1 plus I, so the 2 plus 1,500. So now we don't have future value. This one multiplied by 1 plus I. Okay. And again, this looks like a quadratic. So I'm going to say let 1 plus I equal K. So we're going to get 1,000K squared plus 1,500K minus 2,600 equals 0. Using the quadratic formula, we get K equals 1.02834, or K equals negative 2.52834. Okay, and again, this doesn't make sense because interest rate we assume are always positive, and you can't, if it's negative, then your interest rate can't be positive. So we're going to say this one is again not applicable. So we're only going to use that one. So if that's your K, then 1 plus I must be equal to 1.02834. And if you subtract 1 from both sides, therefore interest rate is 0.28. Let me get the whole full thing from my calculator. 341924. Cool. And we'll save that as A because we're going to have to do a little bit of stuff to this. So we've got this I. Let's write down what this is. This is our yearly effective rate. Okay, we got a yearly effective rate, but we don't want that. The question is asking for I, and it says it's convertible semi-annually, so it's a nominal rate. Cool. So we basically want to convert this to a nominal rate. So the way we do it is we're going to use our formula. So 1 plus I is equal to 1 plus I 2, because it's compounded twice a year, over n, which is 2 to the power of 2. Okay. And we know that this I is like A, which works out over here. So we're going to sub that in. So I'm going to do square root of both sides, or raise both sides to the half. So you're going to get 1 plus I 2 over 2 equals 1 plus A to the half. Then if we subtract 1 from both sides multiplied by 2, we get I2 is equal to 2 multiplied by 1 plus A to the half minus 1. And that should give you 2.81% if you subbed everything in correctly and you saved everything in your calculator. Cool, and that's how you do question 4. Okay, and finally we get to question 5. It says, determine the accumulation in value of an investment of 100 Rand over 20 years, if this investment is due to earn a simple interest rate charge of 5% per annum for the first 5 years, an effective compound rate of interest charge of 7% for the next 3 years, an effective compound rate charge of 0.5% per month over the next 8 years, and a nominal rate of interest charge of 10% per annum compounded twice per year over the last 4 years. Okay, so let's draw a timeline to represent all our interest rates. So we have from time 0 to time 20, interest rate changes after 5 years. And then it says from the next 3 years, that'll go to time 8. And then it says the next 8 years, that'll go to time 16. Okay. So over this period, it says it has simple interest. So I'll put an IS of 5%. Over this period, it says it is just like normal effective interest rate per year of 7%. Over this period, it says you get 0.5% per month. So it's basically monthly, but it's effective because you divide it by 12. And then for the last 4 years, it says you get this interest rate. So yeah, not divided by 2 because it's nominal, and it is 10%. And this one is 0.5%. Okay, and your accumulation is for 100 Rand, I think. Yeah. Okay, cool. So now all we have to do is basically find the future value at time 20, after 20 years. So your future value, we're just going to do it for each period. So it's going to be 100 Rand for 5 years at that interest rate. So it'll be 100 times 1 plus 5% times 5. Because remember, for simple, you multiply it, you don't put it up here. Cool. And now we do another 3 years at a compound interest rate of 7%. So now it's going to be 1 plus 7% to the power of 3. And now it's going to be 1 plus 0.5%. And now we need to do it for the number of months. So it's going to be it's basically 8 years, and each year has 12 months. So I'm just going to do it to the power of 8 times 12. And now for this one, 1 plus, I want to, instead of, this is the nominal rate, we want to get it into an effective half yearly rate. So what I'll do is I'll divide it by 2. So now this is the interest rate per half year. Let me move this across to give me some space. Now this is the interest rate per half year. Now I want to raise the power of the number of half years. So from time 16 to 20, there's 4 years. So it'll be 4 times 2, because there's like 2 half years in each year. And if you plug that into your calculator, you get 365.19. Okay, so this was quite an easy one, and that's your final answer. Perfect. I hope you enjoyed this video, and I'll see you in the next one.